Hollywood films have made us all familiar with the Statue of Liberty. The lady covered in copper who carries the torch of freedom. But close-ups reveal that the Statue of Liberty is green. Surprising, because copper is reddish golden. Well, the copper on the Statue of Liberty has been oxidized to green colored copper oxide. What are the mechanics of this reaction? Meet me in the studio to find out more. Hello, I am Deobrata Goswami. Welcome to the wonderful world of chemistry. Today, we will continue our discussion on redox reactions by learning how to balance them. We will learn how to balance chemical reactions by two methods. We will learn the oxidation number method as well as the half reaction method. Then we will take a look at the half reaction method in acidic and basic medium, and then on to the litmus test, the exam decoded section. Let us start today's session with an experiment. A piece of copper is placed in colorless silver nitrate solution. You can see that a chemical reaction has occurred since the solution turns blue over a period of time. You must have also noticed a silvery coating that is formed on the piece of copper. What happened during this experiment? Why did the solution turn blue? This is because copper atoms from copper strip lost 2 electrons and formed copper ions, which made the solution blue. The silvery coating that is formed on the piece of copper is because the silver ions of silver nitrate solution accept the released electrons to form silver. In this reaction, copper atoms are oxidized to copper ions. Simultaneously, silver ions are reduced to solid silver atoms. So, the net reaction will be copper atom plus 2 silver ions give copper 2 plus ion and 2 silver atoms. This simultaneous occurrence of oxidation and reduction is called redox reaction. In this equation, the oxidation number of copper and silver also change. Recall that oxidation number denotes the oxidation state of an element in a compound ascertained according to a set of rules. These rules are formulated on the basis that electrons in a covalent bond belong entirely to the more electronegative element. In this reaction, the oxidation number of copper increases from 0 to plus 2, therefore it is an oxidation reaction. Recall that oxidation is defined as an increase in oxidation number of an element in the given substance. Also, the oxidation number of silver decreases from plus 1 to 0. Therefore, this is a reduction reaction. Recall that reduction is defined as decrease in oxidation number of an element in the given substance. To balance a redox reaction, two methods are used: oxidation number method and half reaction method. Let us first start with oxidation number method. To understand the oxidation number method, let's take the reaction of iron oxide and carbon. As you can see in this equation, iron oxide is reduced with carbon to iron and carbon monoxide. The first step is to calculate the oxidation number of each element on the reactant and product side. Now, identify the oxidation and reduction reaction. Since oxidation number of iron is decreasing from plus 3 to 0, it is reduction. And since the oxidation number of carbon is increasing from 0 to plus 2, it is oxidation. Now, multiply the change in oxidation number by a suitable coefficient to balance the equation. Now, the next step is to balance oxygen and hydrogen atoms. In this reaction, the number of oxygen atoms is already balanced. Hence, the redox reaction is balanced. You need to practice balancing redox reactions, and for that, you can log on to www.topperlearning.com. It's now time to take a short break. When we come back after the break, we will discuss another method of balancing redox reactions, which is the half reaction method. But before going for a break, here is a question for you. Do you know why calcium hypochlorite is often used for swimming pool sanitation? Welcome back. I am Deobrata Goswami and you are watching Chemistry. Before the break, I had asked you, do you know why calcium hypochlorite is often used for swimming pool sanitation? Well, most of you know the answer, but for those who couldn't get it, let me tell you. Calcium hypochlorite kills the bacteria in water by oxidizing them. That is why it is used in swimming pools. Moving on, let's take a look at another method of balancing redox reactions. This method is based on splitting the redox reaction into two half reactions, oxidation half and reduction half. For example, let us take the redox reaction between iodine and nitric acid. We will first separate the redox reaction into oxidation and reduction half reactions. To do this, we need to calculate the oxidation number of the elements on either side of the redox reaction. Iodine shows an increase in oxidation number from 0 to +5 and is written as oxidation half. Nitrogen in nitric acid has oxidation number +5 and decreases to +4 in NO2. Therefore, this is the reduction half. Each of the oxidation and reduction reactions will be balanced separately. Let us first consider oxidation half reaction. Here, since there is an increase in oxidation number by 5, therefore it will lose 5 electrons. But now, iodine atoms are not balanced. So, let us balance this reaction by multiplying with 2. Now in the next step, we will balance the number of oxygen atoms by adding appropriate number of water molecules on the deficient side. Since the reaction medium is acidic, to balance hydrogen atoms, we will add appropriate number of H+ ions to the deficient side. Since there are 2 hydrogen atoms already present on the product side, we only add 10 H+ ions to the deficient side. We will balance the reduction half reaction in a similar way. First, we balance the decrease in oxidation number by adding the number of electrons to the reactant side. Then we balance the oxygen atoms by adding 1 water molecule to the deficient side. Since there are 3 oxygen atoms on the reactant side and only 2 oxygen atoms on the product side, we add 1 molecule of water to product side to make the number of oxygen atom same on both sides, which is 3 oxygen atoms on either side. Next, we balance the number of hydrogen atoms by adding 1 H+ ion to the reactant side. Again here, since 1 hydrogen is present in HNO3, we add only 1 H+ ion. Once the individual oxidation and reduction reactions are balanced, the loss and gain of electrons is balanced. Since there are 10 electrons in oxidation half reaction and 1 electron in reduction half reaction is multiplied by 10. The two reactions are then added to give a balanced redox reaction. Trust me, if you practice this balancing, it will become quite easy. But right now, we have a student who has called in with a doubt.
I just want to know that is the balancing of redox reaction in basic medium is different from that of acidic medium.
Well, that's a nice question, and the answer is yes. We do balance reactions in acidic and basic media differently. We have H+ ions in an acidic medium and hydroxyl ions in a basic medium. So, we balance hydrogen atoms in the redox reaction differently. Let us take an example to show this. Take a look at the reaction on your screen. First write the oxidation numbers and then separate the redox reaction into oxidation and reduction half reactions. Let's first balance the oxidation half reaction. We balance the oxidation number by adding 3 electrons to the product side. Then we balance oxygen atoms by adding 1 water molecule to the reactant side. But balancing hydrogen atoms depends on whether the medium is basic or acidic. First, we add appropriate number of water molecules to the deficient side and an equal number of hydroxyl ions to the other side. Now, in a similar way, let's balance the reduction half reaction by first balancing the decrease in oxidation number. Then we balance oxygen atoms and then hydrogen atoms. The last step is to balance the loss and gain of electrons. When we add the balanced half reactions, we get the final balanced redox reaction. It's important to balance teaching with a short break to let all the information sink in. You can utilize this break by practicing how to balance redox reactions. For more practice questions, log on to www.topperlearning.com. Meanwhile, I will leave you with something to tease your gray cells. How can one know whether the redox reaction is taking place in basic or acidic medium by studying a given redox reaction? Keep thinking and keep watching. Welcome back. I am Deobrata Goswami and you are watching Chemistry 11. So did you find the answer? Before the break, I had asked you how you can know whether the redox reaction is taking place in basic or acidic medium by studying a given redox reaction. Well, here is the answer. In a chemical equation, if reactants or products have hydrogen ions or an acid, the medium is acidic. If the reaction has hydroxyl ion or a base, then the medium is basic. It's time now for a quick recap. In today's episode, we learned that a redox reaction is balanced by oxidation number method and half reaction method. To balance a redox reaction, first the loss or gain of electrons is balanced, and then all the other atoms except oxygen and hydrogen are balanced. Then oxygen atoms are balanced by adding the appropriate number of water molecules to the deficient side. In the last step, hydrogen atoms are balanced, which is done by adding hydrogen ions in acidic medium and hydroxyl ions and water in basic medium. Now that you have understood these points, no question can baffle you. So get set for exam decoded. Welcome to exam decoded, and it's time for trial by fire. I mean, time for the rapid fire round. Let me quickly run you through the rules again, although I'm sure by now you are well versed with them. 5 questions, 5 seconds for each question, and 1 mark for every right answer. We will then compare scores and see how well you have done. The first question: oxidation number method is used to balance both ionic and redox reactions. True or false? This is true. Next, charge is balanced by adding hydrogen ions to the deficient side in acidic medium. True or false? This is also true. Question 3. In the given reaction, the values of X and Y are A 1 3, B 3 1, C 3 3, D 1 1. The answer is C. It is 3 and 3. Fourth question. The number of electrons required to balance the given reaction is A 1, B 2, C 3, D 4. The answer is C. And the last question. In the given reduction half reaction, electrons gained by chlorine atom is A 2, B 3, C 4, D 5. The answer is C. Chlorine gains 4 electrons as oxidation number of chlorine is +7 in Cl2O7 and +3 in ClO2-. Well, let's see how well you did. If you have scored 5 out of 5, congratulations, you are a high flyer. If you got 4 or 3, you are an achiever. Anything below that means you are a learner. But do not worry. To score more and excel in your exams, log on to www.topperlearning.com, where you can revise and practice till you are perfect. Speaking of perfection, it is also important to know how you can score in this topic. This chapter is from the unit Redox Reactions and is of 3 marks weightage, so is important. Usually 2 or 3 marks questions may be asked to test your conceptual ability. Probable questions from this topic can be balancing of redox reactions using either oxidation number or half reaction method. Now, let's see the ideal question from this topic. Balance the given redox reaction by half reaction method. The reaction is in acidic medium. This question is of average difficulty and is of 3 marks. For balancing the redox reaction, follow each step carefully. Separate the oxidation half and reduction half reactions. Separate the oxidation half and reduction half reactions. You can identify the oxidation and reduction half reactions by calculating the oxidation numbers of each element. Writing the oxidation numbers will fetch you half a mark. Identifying the oxidation and reduction reactions will fetch you another half mark. Each half reaction is balanced separately. So, the next step is to balance the oxidation number by adding the number of electrons. This will fetch you another half mark. There are no oxygen atoms, so balance the hydrogen atoms. Since the reaction takes place in acidic medium, the balancing of hydrogen atoms is done by adding the appropriate number of hydrogen ions to the deficient side. Balancing of hydrogen atoms correctly will fetch you another half mark. Now, both the half reactions have 2 electrons each. So, add the 2 reactions to get a balanced redox reaction. This will fetch you the last 1 mark. And Now it's time to take some expert opinion on how to crack your exams.
For redox balancing, we can use two methods. Number one is ion electron method and number second is oxidation number method. For ion electron method, remember that balance main element first. For balancing of oxygen, add water on the side deficient in oxygen. For balancing of hydrogen, add H plus ion protons to that side where hydrogen is less, and be very careful about balancing of charge. For balancing of charge, add electron to the side where positive charge is more. For oxidation number method, the first task is to find oxidation number of all the elements. Be careful about oxidation state of oxygen because for peroxide and superoxide, oxygen is not -2. Remember that it is -1 and -1. For disproportionation reaction, the same species undergo oxidation as well as reduction.
Well, now it's time to say goodbye, but I will leave you with some food for thought. Do you know that ozone is used to purify water as it destroys bacteria and organic pollutants by oxidizing them? Water that has been sanitized by ozone is free of the unpleasant taste, smell, and byproducts associated with chlorinated water. Keep thinking about the other redox reactions that take place around you. This is Devabrata wishing you a balanced preparation for your exams.